Okay, so the next part we're going to go on to is octane number. So this is talking about fuel that's used in internal combustion engines of cars. And so obviously the point of fuel is to turn the wheels so that you can move. And how the wheels in the car turn is by there's an explosion between petrol and air in the cylinders of the car. Now, I'm no expert on the internal workings of the engine, and you don't need to be either. You just need to understand what happens. And that is that this explosion between petrol and air happens in order to produce power to make the wheels turn. But it needs to happen at the right moment. Sometimes an explosion can happen too early, and that means that the pistons in the engine vibrate and you hear a metallic noise. The pistons knock off of the cylinder. And this is due to the petrol-air reaction occurring when the mixture is compressed rather than being caused by a spark. Now, you don't need to go into any more detail on that. It's just if you were to look up what happens in the cylinder with the pistons in a car engine, you would see that the piston goes up and down. And so when it's going down, compressing the air, that's when these early explosions can happen. It compresses the air reacts with the petrol, causing an explosion, and that causes the piston to vibrate and hit off the cylinder or knock off the side of it, and so this is called knocking. The early explosion of the mixture is referred to as auto ignition. So what you hear is knocking, but the correct term for the early explosion is auto ignition. And this is your definition for it. It's the premature ignition or explosion of the petrol-air mixture before normal ignition of the mixture by a spark takes place. And you just kind of need to know that definition. You don't need to know any detail behind it, really, of that explanation that we just went through. That's just trying to give you some idea of what it is. And from there, what we're going to look at now, what we're focusing on, is the octane number. And the octane number of a fuel is a measure of its ability to resist knocking. So its ability to not allow this auto ignition to happen. And so those are two important definitions, and it's the octane number we're going to focus on now. So we looked at isooctane earlier in the chapter. I gave it to you as one of your examples to name when we were naming branched alkanes. And the reason I did that is because it comes up an awful lot and you need to be able to name it. So its name is 2,2,4-trimethylpentane or isooctane. They will refer to it as isooctane usually, and they'll give you the diagram and ask you to give the IUPAC name for it, which is the official name if you were to name it properly. Isooctane is kind of almost the slang term, I guess, the nickname for it, to make it easier to say. So this one's important because it's a very efficient fuel, and so this was assigned an octane number of 100. So similar to our temperatures were designed around, in degrees Celsius anyway, were designed around water freezing at 0 degrees Celsius and boiling at 100 degrees Celsius. Everything else is relative to that, and that's what they've done with octane number as well. So octane or isooctane is very efficient, so it was given an octane number of 100. Heptane is very inefficient and assigned an octane number of 0. These are the two reference hydrocarbons, like the boiling and freezing of water. So these are just for reference. That's where the numbers are coming from. Factors affecting octane number then. The shorter the alkane, the higher the octane number. So the shorter it is, the length of the chain, the higher the octane number. Now, I do want to just stop there for a second and point out that this is very, very important. octane number comes up a lot, and if they're asking you about it, they're going to ask you about these. Obviously, I'm just noticing here this should say 1, 2, and 3. So you can just ignore that. It should say 1, 2, and 3. There's 3 things you need to know here. The shorter the alkane, the higher the octane number. The more branched the chain, the higher the octane number. So again, you want that, your main chain, you want that to be as short as possible. You could make this have a higher octane number again. If you were to branch it a bit more, you could branch that to make it 2,2-dimethyl propane, and that would have an even higher octane number because it's more branched. And number 3 is that cyclic compound, so anything with a cyclic structure, so a ring structure. It doesn't have to be 6 carbons. There can be, so this is like a hexagon. You can get a pentagon, you could get a square formation, anything like that. So anything with a cyclic structure in it will have a higher octane number than straight chain compounds. So cyclohexane will have a higher octane number than straight chain hexane. Other than that, you don't need to go into too much detail on that. You just need to know these 3 reasons. We're going to look at some other things now that are going to affect how efficient petrol is. But those are your 3 things that affect octane.